Panasonic and a cutting-edge Californian battery company Sila have teamed up to revolutionize the electric vehicle industry. Picture this: a new battery technology that could potentially boost the range of EVs by up to 500 miles on a single charge and slash recharge times to under 10 minutes. This game-changing innovation uses nano-engineered silicone particles to supercharge lithium-ion batteries, promising a 20 to 40% increase in energy density. But it's not just about driving farther and faster. This partnership could reshape global dynamics by reducing the US's reliance on Chinese battery supplies, crucial for everything from smartphones to electric cars. With Sila's breakthrough Titan silicone anode powder, which replaces traditional graphite, we're looking at a pivotal moment in battery tech evolution. Founded by an early Tesla alum, Sila has garnered attention from industry giants like Panasonic and Mercedes-Benz, each recognizing its potential to redefine what's possible in electric mobility. This isn't just about innovation, it's about paving the way for a cleaner, more independent future in transportation. Stay tuned as we delve into how this powdered powerhouse is set to electrify the roads ahead. Speaking to the media, Sila co-founder and CEO Gene Burvey said, "It took us 12 years and 880,000 iterations to get to this point. It's a sophisticated science." Burvey started his career at Tesla, becoming the 7th employee in 2004. He was the lead for Tesla's Roadster battery system, leaving when the company had about 300 employees. After further study, he co-founded Sila with Tesla colleague Alex Jacobs and Gleb Yushin, a materials science professor at Georgia Tech. Together, they have created a company that is poised to change the battery landscape and the future of clean energy. So, what makes this new battery tech so special? Sila technology is based on the idea of using silicone instead of graphite for anodes, the part that releases electrons during discharge. In order to significantly improve a battery's energy density compared to graphite, silicone can store up to 10 times more energy, which means that EVs using silicone anodes can travel longer distances on a single charge. However, silicone also has a major challenge. It swells during repeated charging, creating cracks that reduce the battery life. Sila has overcome this challenge by using nanoscale carbon scaffolding to keep the silicone in check. The scaffolding allows the silicone to expand and contract without breaking, while also providing electrical conductivity and stability. Sila's co-founder and CEO Gene Burvey describes the material as raisin bread, where the raisins are the silicone, and there's a squishy matrix around the raisins with a big outer rind on the particle itself. The rind holds the space and the bread moves aside when the raisins expand. The patented scaffolding process involves silicon-derived silane gas, infiltrating custom carbon lattices. The resulting micron-scale powder is shipped to battery makers, who can use it to replace anywhere from 50 to 100% of the graphite in lithium-ion batteries. This means that battery makers do not need to change their existing manufacturing processes, making it easy to adopt Sila technology. A full fat replacement could deliver a 40% increase in mileage for a typical EV and reduce the weight to 80%. Charge time could be as leisurely as filling a tank of gas. CA says that Titan silicone is about 5 times lighter than graphite and takes up about half the space when fully charged. This makes the batteries more compact and efficient, which is important for EV design and performance. In a press release announcing the agreement with CA, Panasonic said it has a goal of increasing volumetric energy density of its batteries to 1,000 watt-hours per liter by 2030. This is a very ambitious target, as the best batteries in the world today are right around 740 watt-hours per liter, and those are the same numbers that solid-state battery developers claim they can reach. Sila is confident that it can soon reach those levels with its technology that is here now. Graphite is the most widely used anode material for lithium-ion batteries, which power everything from smartphones to electric vehicles. Graphite accounts for up to 60% of the volume of a typical battery cell and plays a crucial role in storing and releasing electrons during charging and discharging cycles. However, graphite is not without its drawbacks, such as limited capacity degradation and environmental concerns. According to a report by the International Energy Agency, IEA, China dominates global production of lithium-ion batteries, making 75% of all such batteries in the world. China also has a strong grip on the supply of natural graphite, which is mined from the earth and then processed into various forms and grades. Benchmark Mineral Intelligence, a leading mining consultancy, estimates that China produces 61% of the world's natural graphite and refines a staggering 98% of the finished graphite material used in batteries and other applications. Silicon, on the other hand, is a promising alternative to graphite, as it has a much higher theoretical capacity and abundance. Silicon is the second most abundant element in the Earth's crust after oxygen and can be found in various forms such as sand, quartz, and clay. One of the main sources of silicon for battery applications is high-purity quartz, which is converted into silane gas and then into silicon wafers. The U.S. is a major producer of high-quality quartz, with mines located in states such as North Carolina, Georgia, and Arkansas. CA's anode powder, which is compatible with existing battery manufacturing processes, has been used in consumer electronics since 2017, when it was first produced in a pilot facility at the company headquarters in Alameda, California. To meet the growing demand for its product, especially from the automotive sector, Sila is now expanding its production capacity by setting up a new factory in Moses Lake, Washington. Moses Lake is a small town in central Washington, known for its potato farming and its proximity to the Columbia River, which provides abundant and cheap hydroelectric power. The town has also become a magnet for emerging industries such as aerospace, data centers, and renewable energy, thanks to its favorable business climate and infrastructure. Sila's new factory, which occupies a 600,000 square foot former fiberglass plant, will initially employ 100 people mostly from the local community and will eventually create 600 more jobs as the company scales up its operations. CA's new factory will be one of the largest and most advanced facilities for silicon anode production in the world and will help the company achieve its vision of enabling better batteries for a better future. Bervy knows that being green is good for business, especially when it comes to serving European customers. A new regulation by the European Parliament in June made it an easy decision for CA to set up shop in Moses Lake. The rule requires that every EV battery sold in the EU market must have a label that shows its carbon footprint. It also mandates that battery passports must digitally track the origin and composition of batteries and their materials. The EU is not the only one that has strict supply chain standards for EV batteries. The Inflation Reduction Act, IRA, of 2022, passed by the U.S. Congress, also imposes certain conditions for EV subsidies to be eligible. Battery minerals must come from domestic sources or from friendly countries. The IRA also sets a target for the U.S. to source 40% of its minerals locally this year and 80% by 2027. Moreover, the IRA bans the use of critical minerals, battery materials, and other components from foreign entities of concern. Bervy explains the implication of this. If you use any material that comes from China in your batteries, then your customers will lose a $7,500 tax credit. CA is not alone in its attraction to the clean energy of Moses Lake. Just a mile away from the old fiberglass plant, Group 14 Technologies is building a new factory that will produce a similar silicone-based powder for Porsche, the German car maker, that was the lead investor in a $614 million funding round for Group 14 last year. The company, founded in 2017, plans to open its plant in 2024 and expects to produce enough of its SEC 55 anode powder for 200,000 EVs per year. Bervy is confident that CA has an edge over its competitors. There are companies that have partnerships and collaborations, but they're all still in development while we're ready for scale production. Moses Lake also hosts Silicon, a former solar panel supplier that was shut down and is now one of the only 2 U.S. makers of silane gas, a key ingredient for silicon anodes. Group 14 will buy its silane from REC. Bervey declines to reveal CA's silane supplier. Both companies received $100 million grants from the federal government to build their silicone anode factories. What do you think about this? Let us know in the comment section.